You guys have made it to the 10th and final video of this unit. Alright, so we will have our mastery check after this video, or after you get the practice done, and then we'll get into our angles unit test. So we're going to put all that vocabulary together. We're going to have a test on everything. So last video here is about the exterior angle theorem in a triangle. So this is something that's a little bit new, but it still helps to know the vocabulary from a triangle, and a linear pair will come up in this video as well. So again, to get started, we want to know the definition of an exterior angle theorem, identify when it's appropriate to use it, set up an equation, and solve for missing angles. There's all things, all kind of go hand in hand with what we've been working on throughout this unit. So the exterior angle theorem states that the exterior angle is equal to the sum of the remote interior angles. That's the two remote interior angles. So first, let's talk about what an exterior angle is. So angle 4 here in this case is our exterior angle, because the angle is outside of the triangle. This is our exterior angle. Now, you can kind of get this definition, I want to say intuitively, but by what the word remote means. Remote means, you know, separate, distant, away from. So this 1 and 2, these are going to be considered our remote angles. So the equation that we can use, or the algebra that we can set up here, is that 1 plus 2 equals angle 4, not 1 plus 2 equals 4. These two angles, whatever they might be, 1 and 2, add up to whatever 4 is. So instead of 180, this is another way that we can set up this equation. Now, little side note here, which I think is important to understand. There's another vocabulary word, that another two things that you can set up kind of in this triangle. We should know at this point that 1 plus 2 plus 3 equals 180. That's from last video. That's a little bit of review. Okay, so make this little review box here. And the other thing that some people have a tough time seeing is this linear pair down here for 3 and 4. So 3 plus 4 is also equal to 180. So this is the new thing. This is our exterior angle theorem. Very, very important. But those two things in review, those interior angles and that linear pair, do come up a lot. All right, so we're just going to jump into some questions. I'm pretty sure there's only 3 questions for this video, so hoping to keep it a little short for you since it is the last one, but we'll see what happens. All right, so first question, solve for angle A. Now, what do I know about this picture? There are 2 important things that I know about this picture. Number 1, I know that A is the exterior angle. How do I know that? It is outside of the triangle. Important thing 2 that I know, this is a isosceles triangle, and I know that because these 2 sides are the same length, which also tells me these 2 angles are going to be the same. So how am I going to solve for that? Well, what I would do is I would take 180 minus 44. That would be the first thing, because then I can find those 2 angles down there. 180 minus 44 is 136. And again, this 136 is between the both of these that I know is the same. So I'm going to divide that by 2 and get 68. So I have 68 here and 68 here. Now, the proper way to do this with the exterior angle theorem would be 44 and 68. So we have 44 plus 68 equals angle A. So we could do 68 plus 44 and get 112 degrees. Again, these would be my remotes since they are not touching angle A. There's another way to do it. If you can think of it, you can leave a comment on the video, or you can show me in class. You can ask me any questions that you have when we're there, but that's going to be it for example 1. Now, example 2, you don't really have any creativity with example 2. This is why the exterior angle theorem is very important. We don't really have much leeway with this. So I know that 3x plus 10 is the exterior angle, and these 2 are the remotes. All right? And I know that because they are not touching 3x minus 10. They are not adjacent to 3x minus 10. This would be the adjacent angle that we are not going to use. So the equation that we are going to set up is we are going to add the two remotes together. So we have 35 plus 35. So we have 35 plus x plus 5 equals 3x minus 10. So I'm going to combine like terms on this side first. So we have x plus 40 equals 3x minus 10. I would subtract x from both sides and add 10 to both sides. So we would get 2x equals 50 and x equals 25. Alright, so that's going to be it for this one. Most important thing, just because the triangle is not always drawn in a favorable orientation or direction, you can always turn your paper if it helps you. This one's drawn a little bit different, but that shouldn't stop you from being able to find that exterior angle and those remote angles so you can set up an equation. Alright, last one's a Regents question. I wanted to put one of these on here because I do find them a little bit challenging because you're not actually solving anything. What it's asking you is you're looking for like what equation could you set up based on the numbers. I find these to be the most challenging questions that we'll see throughout the year, and let's just dissect this question and see if we can get ourselves an answer here. So in the diagram below, triangle ABC, AC is extended through point C to D. So what that means, all this means is AC is extended through point C to D, means that this is one straight line and all these points are collinear, right? So that means anything on that would be considered a linear pair. And it says BE is drawn to AC. So you just kind of connected these dots here, right? So not a lot of helpful information in there, but it says which equation is always true. So when you go through these questions, my suggestion to you is to look at every single question, every single answer. And if you're really good and you're very confident with this, you should not only be able to tell me the correct answer, but you should be able to tell me why each one is wrong. So let's start with the first one. The first one says angle 1 is equal to angle 3 plus angle 2. So angle 1 is equal to angle 3 plus angle 2. Now, that's incorrect. And the reason why is angle 2 is not a remote angle. If I wanted to fix that, it would be angle 4, right? I would be looking at this triangle, and I would say that angle 1 is equal to 3 and 4. That would be my remote angles. So that one is not going to be correct. Right? Let's see about angle 2. Question 2, choice 2. Sorry. So we have angle 5, way out here, is equal to angle 3 minus angle 2. Well, we got two problems with this. The two issues is that 5 is not the exterior angle, and it should be plus, not minus. So the exterior angle of 3 and 2, if you look at the picture, and I'll try to draw it out separate when we get to that one, should be 7. So that's why that one's not going to be right. And we can kind of say the same thing for choice 3. Down here, choice 3 is angle 6 is 3 minus 2. Now if you notice, all of these choices have to do with 3 and 2. So if I'm looking at this picture, or I'm looking at these answers, when I see angle 3 and angle 2, which angle is the appropriate exterior angle for this, and which one is plus? So the answer is going to be 7. The answer is going to be choice 4. So there's a couple ways to look at this, right, as you go through this. First, you have to understand that they're dealing with exterior angles here. So you know that choices 2 and choices 3 are no good because they're both minus. It's got to be between choice 1 and choice 4. And then you just have to pick the appropriate remote angle or the appropriate exterior angle. So if you're having a tough time seeing why 7 is the correct answer, what I can try to do is, if we set this up here, 3 and 2 are the remotes, and 7 is the exterior that we worked on in the last one. All right, we got a ton of practice set up for this one. This is your last video, last mastery check. If you have any questions, let me know, and see you guys in the next chapter. Great job.